All right, here we go. Hopefully this works for everybody today. This will be about 5 or 10, I'd say about 10 minutes long. Feel free to pause and play as needed. You will be instructed to do certain things throughout the video that you'll need in your next step after the video. So make sure you do the things that I ask you to do so you're prepared for the next step. And again, pause and play as you need. So what we're going to have is we're going to have the first problem. I'm going to go through and I'm going to do everything. I'm going to model everything off of this problem. And then I'm going to ask you to copy 2 tables down yourself. They'll be below. I'll show them to you in a minute. And then you'll have to do the same thing with those 2 tables. So if you need to jot down any notes on this first problem, feel free. If not, you can watch it. If you need to watch it again in the next section or the next step, that's fine. If you need to go back and review, I have no problem with that. So here we go. First table that we have is between the proportional relationship between dogs and cats. Now, listen, we know that cats are inferior and that there's way more cats per dog in this one. Not the point. The fact of the matter is we have a proportional relationship between dogs to cats. That relationship, and we can call these up here, the dogs, we'll call that X, and we'll call the cats Y, okay? And the relationship that we have here is there's a connection between all X to Y values. And that connection that we have from all X to Y values is called the constant of proportionality. I think I spelled that right. I did. All right. Now, all along, I believe we've all had not much issue with trying to find that constant of proportionality going from X to Y when the number's getting bigger. So we know that there's a multiplier here. We have to multiply each one of these dog values by 5 to get the amount of cats. So we can say that our constant of proportionality is 5. This is really important. The reason why this is so important is because this is going to help us write our equation here in a minute, okay? However, before we move on to the equation, let's have a hypothetical. The hypothetical is, let's imagine for a second that we're going in the other direction, and we're going from Y to X. And this is where a lot of us have had some struggles, because immediately we want to go through and we want to say that the rule is divide by 5. Now, mathematically, I don't disagree with this at all. That is correct math to say 15 divided by 5 is 3, 10 divided by 5 is 2, and 5 divided by 5 is 1. However, when we are writing a constant of proportionality, it must be written using the operation of multiplication. So I'm going to make these white lines disappear, and we're going to talk about how this 5 right here of going from X to Y can very easily be written as a constant of proportionality going from Y to X. And if you remember when we did scale factor, we kind of already covered this a little bit, all right? So to go in the opposite direction and still use multiplication. So again, we're going back from cats to dogs. All we do is we write the reciprocal of this fraction, and we say 1 over 5. So if we were to ask what the rule was going from cats to dogs, it would be 1/5. We still use that same idea of 3 to 15 would be times 5, but we flip it so we can keep it multiplication to go in the opposite direction. So I'm going to take off all this white on here, and we're going to get back to the red. All right. So we've already kind of discussed that constant of proportionality of 5, that's going to allow us to write the equation. Okay? So the equation is going to be in the form of kx is equal to y, meaning that any value, this k here, this constant proportionality, can be multiplied by any value of x to always equal the y. Okay? So if I were to write this out, our equation would be 5x equals y. All right, I'll give you a second if you want to write this down. I'll wait. Go ahead and pause if you need to. All right, moving on. Graphing. If we were to go through and graph this, give me 1 second. We know that the horizontal axis is always the x values, and the vertical axis is always the y-axis. Now, also importantly, we know that this origin down here is represented as the point of 0, 0. This is going to be very important for these types of equations. All right, so let's go ahead and go through and graph these points. So our x values, again, are right here. That's all of these, okay? And our y values, I'll underline these, are right here. There's our y value. That was not good. There's our y value. So I have this down here of 1, 2, 3, 4. Wow, that's horrible. 4, 5, 6. Why did I count by ones? Because the dog amounts count by 1. I need to count by consistent intervals, which means you got to count by the same number each time, starting at 0. So the next one I can count by 5. So 5, 10, 15, 20, 25, and 30. From here I can graph. Let's pick another color. Ooh, that's pretty. All right, let's go with 1, 5, 2, 10, and 3, 15. Now, as we've talked about in class, we know that when we have these points, if it's this kind of equation, this proportionality equation, we know that all those points will lay on the same line, and they must form a straight line hitting the point of 0, 0, the origin. Okay? So pause for a second if you need to. If you got to rewind, so be it. No big deal. All right? I'm going to go off to this equation. I'm going to take this a couple steps further. So the x value here, again, means dogs. The cat's value is y. So the reason why the equation is going to become important as you go through 7th and 8th grade and even into high school is there's going to be questions that say, what if we have 30 dogs? How many cats will we have? Okay, so sure, I guess I could go through and make this graph way bigger, but it seems a lot easier to me that, hey, we have the dog amount, and we have this equation. Anything that's proportional and means the same thing, just changes size, I can plug those values in. So I know that I have 30 dogs, and that's the value of x. So 5 times 30 is going to tell me y number of cats. So I know for 30 dogs, I have y equals 150 cats. Okay? Now, that goes the other way as well. What if I say, and I'll even use the same number. Let's say I have 150 cats. Well, that's a y value. You can plug that value in for y, use the same equation, and solve for x. Now, we know how to solve this. We're going to divide both sides by 5. And look at that. In this case, we know that x is 30 dogs. So we can use this equation for finding x amount of dogs or y amount of cats. All right, I'm going to scroll down. It's important for you now to write down the tables that I'm about to show you. You're going to go through. You will have a handout. If I didn't already give it to you, you'll get it in the next station. You're going to have a handout where you're going to have to answer these kinds of questions here. So if you needed to make notes, And if you run out of time, you'll have time to finish your notes in the next section. So I'm going to scroll down, and I want you to go ahead and write this. You'll probably have to pause the video. And I'm going to scroll down, and you're going to write this one. And get ready to move to the next station. All right, if you have some extra time, go back and watch it. That would be great. That would be fantastic.